Getting okay, right. Presentation is visible to everyone.
Yes, ma'am, it is visible. It is visible. Please go ahead.
Ladies and gentlemen, so today we are here with applications of machine learning. So before starting with my session, I women for inviting me in 5 days national level FTP, and I also would like to quote Professor Kiran Shri sir and his team for organizing the FTP in such a way. So let's start with the session. So I'm going through with the elementary, and I will give you a number of application areas and examples through which we can relate. Today in this section of statistics for machine learning, basically we will, and also how it is used in machine learning, artificial intelligence. So to begin with, let's have a look to the definition of statistics. And before my interactive session, so that the listeners also respond to the and so I wanted that you must also respond to my questions if you. So before my explanation for this particular thing, what is statistics, what is machine learning, so I would that what is their opinion, what is according to them, what is the statistics exactly. Anyone? Okay, all right. So much of time. Yes, I got a response to predict. Okay. Anyone else? Okay. Very nice. It's very good.
I'm organizing in a purposeful manner.
Very nice. Yes.
Organizing data in a purposeful manner.
Number of responses, very nice. It seems to be a very good. All the answers are correct, and therefore here the definition also is the art of never saying, never having to say you are wrong. All right. So nobody is wrong. Everybody's answer has its own limitation. Okay. So for an instance, I can show you a data which would. Anyone tell me that what is the relation here between data A and data B? At the written the data A, data B, and I have written some numerals in front of them. Okay, someone has
a multi
range. Nice. Yes, very nice, sir. So data A and data B is related by a factor of 2, right? Or you can say the multiple of 2. So that means there is a relation between data. Find any labels to these two datas, data A and data B. Okay, so if you want to reduce amount of B, then you have to reduce the amount of A. Correct? Now, does that mean now? But what if I tell you that A representing the number of people who are using Android phone, Okay, and data who are basically dying in a car accident. More people buying an Android phone would cause death.
No, ma'am.
Statistics say so. Here we can see that statistic is basically revealing this fact. Two are completely a random activity. So how do you know that you are comparing correct variables? See, there is no way of knowing. This is the basic limitation of statistics. Okay, so it to compare those variables or not. Okay, you will have to rely on no relation between an Android phone user and a number of people dying. Right. Therefore, I would on your logical abilities while using a statistical method. So statistics always show you some result on your, or it will show you some outcomes, but it's your instinct, it's your responsibility to make it logically correct and acceptable. What is statistics? What is the basic meaning, or what is the layman meaning of the statistics? So we can that basically represents something. Okay, so for an instance, anything around you, numerical value, is basically a data, and that data is the basic sense of the statistic. Okay, on a chair, and you start observing like what is the weight of the chair, how much did you pay for it. So all these things you can measure quantitatively, and you can store it. Okay, and you can data for the further analysis, right? So this basically comprised of statistic, because here all the numerals, all the things kept for as a part of your data is basically representing the with the chair. Next we have the concept of machine learning. You have gone through a number of machine learning algorithms and machine learning applications, and one of them is the recommendation. This is also one of the recommendation system that customers who have bought left leg shoe also bought the right leg shoe. Okay, recommendation. But actually, when we talk about the machine learning, so machine learning basically provides to learn without being explicitly programmed, right? So we are making machines able to learn through its experience. Okay, we also learn from our experiences. We also learn from our environment. Okay, um, uh, we don't know about the expressions, we don't know about the languages, about the relations, about the machine also requires experience. Machine also environment to create its own intelligence, to create its own pattern recognition, right? Deeply. So consider you are trying to throw a pencil into the drawer. All right. So you are, while throwing, you realize that sometimes you have put too much of force in it. Okay. To the target, but you need to increase your throw angle. And sometimes you got diverted from the target. All right. So throwing the pencil to the drawer. All right. So basically, what is happening here? After every throw and improving the end result, we can say, it can be said that we are learning and we can conclude that you are programmed in such a way. Okay, because you're yourself as per the observations that you have seen right now. Okay, now we can do something similar. We can program a machine to learn from every attempts, every experience, every data point. Consider the same example for a machine and non-machine learning program. All right. So in case of non-general program, you would tell computer to measure the distance and angle and apply some predefined factor of a wind force using fan to your setup. If you add up another factor, if you change the environment, means right now you were trying to throw you had changed the space as an open space. So this program will continuously miss target from its failed attempt. You have defined the angle, the distance, but you have not mentioned the affecting your throw. Okay, so when we add up some new factors, work based on the particular factoring. Okay, so to get the outcome right, you need to and you have to keep in mind all learning program. But if we go by the machine learning program, so machine would begin with the generic generic program, or you can say the generic formula. But after every attempt, refactor its formula. Factor its formula. So as the formula is continuously improved using more experience. So here, the data points that we are talking about are the experiences that you are adding for a machine. And basically, we all see these things into action around us, usually in terms of YouTube videos, lots of many applications wherein we can see this one. Okay, so what is statistics and what is machine learning separately. Now let's see them together. I found and thought to share with all of you. So before proceeding further, first purpose and credibility has also been mentioned here. So what I reflects what is the statistics for machine learning. So we can say we are not just trying to glorify statistics or collection using you can say using machine learning, but also we are providing greater boundaries to the statistics. Deny the fact that the statistics is one of the prerequisites to the machine learning. All right, so through the raw image, right, which we have called as a statistics because it is the raw representation, and in the further statistics using the machine learning algorithms, you have identified the unseen patterns and you have basically covered it with the machine learning algorithm. Clear picture of how we can proceed from statistics to machine learning, and then we can proceed to the artificial intelligence. Why I'm saying that the statistics is one of the prerequisites to the machine learning. Okay, so it is must to observe the data, to explore the descriptives associated with the perform this, then probably you may lose direction learning algorithms, and probably you could do a disaster, right? Because you are going without any plan, you are going without data, so you are not very clear about what machine learning algorithm should be used for a particular type of data. I am saying that statistics is the first step towards the machine learning. All right. So therefore, understand significance of statistics, which is required for machine learning. This is the core component of data analytics and machine learning, and it basically helps you to analyze and visualize data. The previous slides also. Okay, so statistical methods are your face, and the 5 major reasons I have mentioned here. Statistics, model selection, model presentation, and prediction. Okay, so we can discuss briefly one by one. So when it comes to the data preparation, so when we statistical methods are basically required in the preparation of train and test the data for this particular task. The most popular techniques that can be used, I have mentioned here. The techniques. So we do have many other techniques for data preparation, data distribution, descriptive statistics, and data visualization is required to help to choose when performing data preparation. Okay. In case of application, so statistical methods are required when evaluating the skill of a machine learning model on data. Many of you have used this particular methodology, and this is the most popular resampling method here, which is used for the model evaluation, most widely used. The statistical hypothesis testing might be used difference between the results or to quantify the size of the difference between the results. All right. The presentation, the estimation statistics, such as you can say, might be included for presenting the skill of a final model to a stakeholder. So therefore, with the help of summarizing model on average and quantifying the expected variability of the you can say variability of the presentation could very effective and very appeal. Okay. Statistical methods are also required when making a prediction with a finalized model on a new data. So this includes techniques for, and this might include estimation statistics such as prediction intervals. Okay, so with the help of the prediction goes well or not. All right. Now we have arrived to a point where understanding the data, statistics is the first step. Okay, so as we all know that and inferential statistics are the two major areas of statistics. So the descriptive statistics are for describing and you can say population data. So sample and population data basically reveals what has happened. And inferential statistics use those properties basically to test hypotheses So basically, what can you expect can be drawn from the inferential statistics. So since we have already talked about that the descriptive statistics properties of sample and population data. Therefore, let's first discuss about the population and sample. The population comprises all the observation, or you can say data points about the subject under by sample. So sample, you can think like it is a subset of the population. So it is a small for an instance, if I give you an example. So if we think like that there is a which would like to know all the pet stores who basically sells canned fish. Okay, so a company has the total number of pet stores on a particular place. Let's suppose I'll take the example of Delhi. Okay, and now this pet a research sample. It will filter down the population uh, to a particular type of. Okay, so this would be considered as the sample. So at the first level, the particular company has considered all the pet stores selling cane fish, and then they have filtered it down to the cat stores only. So when we are considering all the pet stores, and when we come to the when we come to only those related to the pets which are okay. So basically, population you can say is the right. Now next is let's see. So central tendency. So this is used to describe the distribution of data using a single value. Okay. So mean measures of central tendency. Mean is basically the average of all the data points and is very sensitive to outliers. That mean is very sensitive to outliers. Okay, and median is the middle value that divides the data into. Okay, once you have sorted the data in ascending order, so you can divide the whole data into two equal parts. Okay. Value that occurs most often. So median and mode both, if we go by the outliers, so these methodologies or both these measures of central tendencies, which are resistant to the outliers, right? These can be used to rank data in the context of consumer preferences and rating when you want to keep inventory, the most popular shirt in terms of color or festive season. Okay, let's do a small, simple and basic activity. And medium both try to measure the central tendency in a data set. So basically the goal of each is to of a typical value in the data set. All right. So now let's try to identify that for the given scenario, which I am showing you, which is considered to be the best measure of central tendency. So I request each one of you to please try once. Score for the Gulf team members. So can you please write the set that we can see here? Team members, 6 members. So we need mean score. So I got tell me the mean score. You have to identify the average. Mean is nothing but the average. All right. So what would be your interpretation for this same? How would you interpret
Sum
it?
of all divided by the number of the data.
Basically, tell.
The average means 6 students are there. So the average score is if we take the average of class.
Okay.
Score that will be 81.
To explain here, we got mean score as 81, right? So a golfer has scored the same. Would have scored the mean. We can interpret it if they have scored same at the same value. So basically, they have scored the mean. Interpret from the mean. Now, when it comes to the median, so what will be the median score? Here we have even number. Have to identify a middle value.
75.
75.
So you can take 74 plus 76 divided by 2. Then how would you interpret it? For the median score?
Below 75 or above 75 are good.
Particular manner, whether ascending or descending. The middle figure will be.
Yeah. So we got 75 as a median score, right? So what we can say is higher than the median. Half of the team has scored higher than median, and from the basic statistical methods. Okay. Now central tendency.
This data is skewed towards the higher value.
Skewed, all right, but how would you say that it is a skew? Wanted that we have studied mean and median, all right? हमने use with the help of mean and median. So with the help of those scores, how would you suggest and what would you measure a central tendency? I have to fill this blank as far as your option is considered.
It's mean.
Mean and somebody saying I think the answer should be median. If you go by the mean value, okay, mean is higher than almost all of the scores in the data set. You can see here, just because of particular value, mean is very sensitive to the outliers. So these values are okay. This particular value, the mean has been shifted to the highest number, right? And we can see that almost all of the scores in the data set, almost, only less than with 114. But if I talk about the median, 5. Now, if I increase this particular number by thousands, okay, median will not be affected. Increase this particular value to the number, the average will shift it to this way. Whether to use the middle value, when to use when we are basically creating the applications of the machine learning. All right. So have tried to identify where we can use the measure of central tendency of dispersion. Okay, so that majorly includes range, quartile. Then it's simply a difference between maximum and minimum value. Okay. It is used in real life to make mathematical calculations. So range can be used to calculate the asked already. Like for an example, when calculating the age, okay, so the current age is 2020. 2000 or 2005 or before that or after that. So you are basically different. You are creating when you born. So here it is the basic example of the range. And if we talk about the quartile, two quarters. Okay. However, quartiles are shaped like your data into 4 segments according to where the number falls on the number line. The 4 are the lowest 25% of the numbers. Sorry. This is the lowest one. Lowest 25% of the number. The next lowest 25%. The second highest 25% of the number above the median. And the highest 25%. So to understand quartiles, the simplest example is the calculation of percentiles. So then basically that means 25% of the people in the class did better than you. People in the class did worse than you. All right. Similarly, in case of quartiles, we are dividing the data set into quarter is 25% of the total number of data points. Okay. Now, the data set such that the 25% of the data and 75% of the data set is greater than this value. Similarly, when we go by the second quartile or Q2 data set such that the 50% of the data points are less than the value and the 50% of the data set are greater 25 and 25% of ratio. Okay. Now, this is basic concept of the standard deviation, which is considered to be the most important measure. So it is a measure of the amount of variation, or you can say dispersion of a set of values. So in mathematical, it is this basically square root of the variance. So variance and standard deviation represents the measure. It basically means how well the mean represents the data, how far they are from the mean. For instance, let's company, there is a constant tussle between employees that they get paid less than others and claim that it is employer did. The employer checked for disparities by calculating the average salary deviation for employees in the particular department. Now, if the standard deviation is higher than the expected, the matter basically is of concern. For example, when going to the accounts, the employer will realize data is skewed. The employees are almost 10 years senior to the others. So this is what we try to understand standard deviation. We try to calculate standard deviation. Data is closer to the mean or it is far away from the mean. It is not affected by the outliers. Okay. Another example that you can take it here is related to your everyday expenditure for you to spend, and check if you are spending too much using standard deviation. Do it by calculating the standard deviation. You are not applying any mathematical formula there, but yes, it's simply an calculation. You did it and your mind basically does it for you, right? Now by machine learning, so it can be concluded that statistics is a core conclusion. By analyzing raw data, we can thought statistics as a pillar of understanding and application of machine learning. Without it, why I'm saying so, because answers to important questions about the data. You can use descriptive statistical raw observations into information that you can understand and share. You can use inferential statistical methods of data to whole domains. All right. Since the raw observation alone are all right. So basically, data raises some questions which are mandatory to be answered before going for any machine learning algorithm implementation. And that questions could be, what is the most common or observation? What does the data look like? Difference between the two experiments, two tests that we have in the real or result of noise in the data. So the results matters to the stakeholders and to the effective decision makers. All right. So statistical methods are required to find answers to the questions data. To both understand the data used to train a machine learning model, results of testing different machine learning models, statistical methods are highly required. Okay. The tip of the iceberg, as each step in predictive modeling or any machine learning model method. So as a machine learning practitioner, I would suggest you must have a good understanding of this. I think that's it from my side, and there is a lot more to share about this particular huge topic, so widely covered topic. So I hope I have justified the topic. I have. Um, Thank you for being an awesome audience. Thank you very much. If anyone has
explanation and avoiding the misconceptions between machine learning. So as of now, we thought of statistics means only calculations and all. But you, thank you so much, madam. I would like to invite Dr. Selvanayaki, Concordia University, Chicago. Welcome you, madam.
Yeah, thank you.
Madam, I hope
I'm sorry.
completed the theoretical part of this machine learning. So we expect that please guide us and apply these machine learning techniques in a practical with a case study, ma'am, in the machine learning. So now,
Yeah. Yes. Sure.
is yours, ma'am.
Just give the rights to share my content. Yeah.
Yeah.
Almost 1 hour.
I can just.
Okay, thank you.
My content. Yeah. I can do it. Yes.
Check it, ma'am. Yeah.
Time limit. What I'm going to do is let me just go straight into the and let me just go into the case study and give you a brief outlook of what is this particular session core work. Okay. So this is what is the agenda.